Welcome in. It is Mr. Ensminger here with our first video on applications using arrays. Let's have a new project here. Just call this array application video 1 whenever and whatever period. So I'm going to put in all my standard stuff. I'm also going to be using random numbers in a lot of these simply because arrays lend themselves well, some of the applications lend themselves well to using random numbers. So I'll also put in the standard library and I'll put in time as well. At the top of my code, I know it's been a little bit since we've done random numbers. Don't forget, you want to put an sran times 0 at the top of your main function. That'll set up the random number generator so that every time you run this, it'll truly be random numbers. So as far as arrays go, this is the first video. Hopefully you're watching this after you have had the first class of the week when I introduce arrays. So let's just keep it basic for right now. We will make an array of size 10, let's say. So when I declare a variable, just like a variable type, we have int, for example, and let's call it nums, and then a size 10. So one of the most important things to understand about arrays, you have of course 10 elements. They're numbered 0 through 9. If I traverse through the array at the moment without having any numbers in there, if I say go from 0 up to and include 9, or of course you go up to but don't include 10, if I print out the loop variable for the index, the location in the array. Again, as I mentioned in class, I'm sure, you can think of this like a spreadsheet. You can think of this as a column or a row of numbers. They're numbered 0 through 9. But if you declare the array without initializing, you will get a whole bunch of garbage. They do not automatically default to 0. You get this, relatively large number. What is that? 460. So negative 858 million. Basically disregard that number. It has no meaning to us whatsoever. So when you declare this array, don't just access it without filling it. It's even giving you a warning right here saying uninitialized memory. What I'll do is I will first declare the array, which remember gives it a name and type, but also in this case the size, because you're doing an array. It's not just a variable where you have name and size. You also have name and type, I should say. You also have name, type, and the size of it. Then I will fill the array with random numbers, and let's say dice rolls 1 to 6. So I have a for loop still, 0 to 9, but instead of printing anything out, I will say instead nums x equals rand mod 6 plus 1. That'll fill the array. Then what I can do is I can go back through and do something with it. Filled in, we already did. We could total up the numbers. We could average the numbers. So again, we're going to keep it simple for right now. We are going to sum the numbers in the array. Now, just to be clear on this, I could do this all in one array. Like I could generate the number and I could total up all at once. The reason I'm not doing it here is because eventually you're going to be splitting this up into functions. So I know it seems wasteful that we're going to be doing multiple for loops with this, but again, there's a method to my madness here, so just trust me. Yes, I know we're going to be doing 0 to 9 a couple times here, but deal with it, basically. So if I go back through and I say, once again, x goes from 0 up to 9, don't include 10, total equals total plus nums x, which of course, if we're using total, we had better declare total. So go up here in total, but because an accumulator, you should also initialize it to 0. So int total equals 0. So I filled the array. I now sum the numbers in the array. Total plus equals nums x, or total equals total plus nums x. From there, I can print the total. And I can say something like not 4, cout the total is equal to, and then I can put total end out. Now, of course, what's lacking in this problem, we don't know what the dice rolls are, so I should put that somewhere. Again, if I'm keeping everything separate, one loop per operation, what I could do is say print the numbers in the array once it is filled. For int x, maybe we've heard this before, int x equals 0, x goes up to and includes 9, x plus plus, cout nums x with an end out after it. So I declare fill, print, sum, and print the answer. If I run this, there you go. 2631, of course it's random, so you're going to get different numbers than I am. But, you know, using probability, averages, the average dice roll, if you have something of 1 to 6, is going to be like 3.5-ish, 3.5. So if you take that times 10, your total is going to be roughly 35. So my answer is 32. Of course, with probability, like theoretically, I could get all 1s, I could get all 6s. I don't know. The more you do this, the closer it's going to get to that number of rolls times 3.5, but ours is going to be off a little bit, and here you see it's 3.2. Does any of that really matter in the grand scheme of things? No. It's the math, the way it works. So before I wrap this up, you know, when you take a look at that, as I said, right now it's multiple separate for loops. Do I really have to do that? The answer is no. The reason I did that is because I want you to see the steps involved, the fill, the print, the sum. When we do arrays with functions, each of those functions is going to be its own little task. Fill the array, print the array, sum the array. And so you can clearly see now here how that's going to be done. But if I were just doing this in one self-contained program, all I really need to do is to put some brackets there and then take each of these lines of code and put them in like such. And now you have, if I get rid of this other stuff, that program works just as well. It's just that I didn't separate the actions as I would if I were doing functions. We're filling the array, we are printing the results, and we are also totaling the results. So, adding, totaling, summing the results, whatever. Program still works just fine. So, whether you do those in multiple for loops or whether you just keep it in one, that's perfectly fine. But to take this a step further, we can now quickly do the average. We have the total, and we know there's 10 numbers, so we could really quickly do the average. If I come down here and I say find the average, cout the average is equal to the total divided by 10. And that might work, however, okay, see, that's what I'm saying, it might work. I got 40, and the average of that, 40 divided by 10, that's 4. Yay, but here's why you want to test your program multiple times. If you have 10 rolls and you have 31, your average should be 3.1, 31 divided by 10. It doesn't in this case because we're using integers instead of doubles. And so therefore, please make sure that you trick it somehow into thinking it's a decimal 10 or 10.0. You probably want to do 10.0, otherwise you're not going to get that accurate answer. And there, of course, is trying to prove me wrong. 30 divided by 10 is 3. Trying to get all these great examples. There you go. 37 divided by 10 is 3.7. QED. So I'll be back with more applications of arrays in a bit. Thanks for watching. Take care.